Good day viewers, this is Simplify Maths YouTube channel analyzing logarithms like John Napier. Lesson 3, Logarithm 1. Subscribe. John Napier is a Scottish mathematician. Invented logarithms in 1614. Logarithms simplify multiplication and division by converting them into addition and subtraction, respectively. His work revolutionized mathematical calculations and has significant applications in various fields. Lesson objectives: 1. Laws of logarithm. 2. Application of the laws of logarithm. 3. Further examples on laws of logarithm. 4. Simplification of problems on logarithm. Let's consider laws governing mathematical operations involving logarithm. We consider the first law. The first law tells us log PQ base A is equal to log P base A plus log Q base A. And we can have this one, let's say we have log 6 base 2 plus log 5 base 2. This simply means log 6 times 5 base 2, which is going to give us log 30 base 2. We consider the second law. It tells us log P divided by Q base A is equal to log P base A minus log Q base A. In mathematics, we can have it application. We have like this: log 8 over 4 base A is the same thing as log 8 base A minus log 4 base A. Now we go to the third law of logarithm. The third law of logarithm tells us log P raised to the power x base A is the same thing as S log P base A. In mathematical application, we can have it this way: log 2 raised to the power 3 base 2 is equal to 3 log 2 base 2. Then we look at the fourth law. The fourth law of logarithm tells us if log n, if log n base 2 is equal to s, this simply means 2 raised to the power s is equal to n. Then we look at law 5. The fifth law of logarithm tells us log a base A is equal to 1. Similarly, when we add the log 5 base 5 is equal to 1, as far as the power and the base are equal, its value is equivalent to 1. Then we look at sixth law. The sixth law of logarithm tells us log 1 base A is equal to 0. That is to say, A raised to the power 0 is equal to 1. Then we go to the seventh law of logarithm. The seventh law of logarithm tells us that the default base for logarithm is base 10. That is to say, if you have log 2, for instance, it simply means log 2 base 10. When we have log 5, in that case, it is the same thing as log 5 base 10. So the default base for logarithm is log 10. So, number 8 law. Now let's take note of this. When we have log 18, for instance, a mathematical operation Involving logarithm, this one does not mean or imply. It does not imply log 6 plus log 12. It doesn't go that way. Log 6 log plus log 12 will be equivalent to log 6 times 12, which is equal to log 72. Now we go to the next slide. In this case, we want to consider problems involving logarithms. Let's take first question. If y minus 1 log 4 base 10 equals y log 16 base 10 without using mathematical tables or calculator, find the value of y. In solving this problem, you can write this like this, having it like this: log 4 raised by y minus 1 base 10 is equal to log 16 raised by y base 10. So we have it this way: log 2 raised by 2 into y minus 1 base 10 is equal to log 4 raised to the power 2, or let's go directly to 2 now. It now becomes 2 raised to the power 4, that's 2 raised to the power 4 equal to 16. Then y, this one simply means we have 2 raised to the power, that is 2 raised to the power 2 minus 1, 2 raised to the power 2 into y minus 1 from what we have in the last slide is equivalent to, we have base 10 here, equal to 2 raised to the power 4y equals to 2 raised to the power 4y. And this case, it means 2 raised to the power 2 into y minus 1 is equal to 4y. Open the bracket, they have 2y minus 2 equals to 4y. Then which means we can see minus 2 is equal to 4y minus 2y, which is equal to minus 2 equals to 2y, and y will be equal to 2 minus 2 over 2, which is equal to minus 1. So our value of y here is minus 1. So we look at the next question now. Consider the next question, which is question 2. Solve for s when we are given 2 raised by s plus 4 equals to 5 raised by s. Given log 2 equal to 0.3010, log 5 equals to 0.6990. In solving this problem, you can have it this way, that log 2 raised by s plus 4 is equal to log 5 raised by s. And this simply means s plus 4 log 2 is equal to s log 5. You open the bracket here, it becomes s log 2 plus 4 log 2 is equal to s log 5. And which means 4 log 2 is equal to s log 5 minus s log 2. Now we can move to the next slide. 4 log 2 simply means 4 times 0.3010. You substitute for log 2 in the equation as we have it. Then from the last slide we have log 5. Now you factorize x into log 5 minus log 2, and this will give you 0, 4 times 0, 0, 4, 0, 2, 1.2040 is equal to s into log 5 as we are given the question is 0.6 690. So you have to substitute here 0.6990 minus log 2 is 0.3010. Then from here we have 1.2040 is equal to s into, when you subtract this, it's going to give us 0. That is 9 minus 1, 8. 9 minus 0, 9. 6 minus 3, 3. That is 0.3980. Therefore, S value will be 1.2040 divided by 0.3980. Let's quickly calculate that. That one is going to give us, we have 1.240, 1.240, 2040 divided by 0.38, 39. I'm going to the calculation to see what it's going to give us. We have, yes, let's see what it's going to give us. So the value is 3.0025. It's giving us 3.025, which is approximately 3.03. That is the S value. Now we move to the next question now. We look at question 3. The question 3 tells us, evaluate 2 log 9 base 3 multiplied by log 81 raised to power minus 2 base 3 divided by log 625 base 5. Now equally, you can write this in this form. It will now become log 9. 9 log 9 is 3 square. So you bring the 2 there, it becomes times 2. This 2 will come this way to the power. Then base 3 is equal to log 3 raised to power 4, that is 81 is 3 raised to power 4, multiplied by the power there, which is minus 2, then base 3. In this case, we have log 3 raised to power 4, then this is t over log divided by log 625. Log 625 base 5. 625 is 5 raised to power 5, 5 place, then log 5. Then it becomes log 3 raised to power 4 base 3 times log 3 into 4 times minus 2, that is minus 8, then base 3 divided by log 5 will be 5 times 1, because log 4 is 1. So it's going to give us, let's go to the next page now. It's going to give us log 3 raised to power 4 base 3 multiplied by log 3. That's 3 raised to power minus 8 as log 3 raised to power minus 8 base 3 divided by 5. So this will give us log 3, 4 minus 8 base 3 over 5. And this will give us minus 4 log 3 base 3 over 5. And this will give us log 3 is 1. So it becomes minus 4 over 5. That's the answer. Then we now move to the next question now. The next question is question 4. It tells us, given that log 2 base 10 is equal to 0.3010 and log 3 base 10 equals 0.4771, Evaluate and correct to two significant figures without using mathematical tables or calculated log 1.125. Log 1.125, it can be written as 1125 divided by 1000. Now let us split it. Let's break it. 5 here is 210. In 12 is 210. In 25, 5. 5 is 2. Here is 00. 5 here is 40. 5 here is 4. 20 and 25, 5. 5 here is 9. 5 here is 8, which is equal to log 9 over 8. And we have this, can have this one in the next slide. We have log 9 over 8 in applying logarithm law is the same thing as log 9 minus log 8, and this means log 3 square minus log 2 raised to the power 3, because 3 square is 9, 2 raised to the power 3 is 8. So it becomes 2 log 3 minus 3 log 2. And since we know that log 3 is 0.4771, so we have to substitute here. 2 times 0.4771 minus 3 times log 2 is 0.3010. So this will give us 2 times this, it give us 2, 14, 10, 15, 1, 8, 9. 0.9542 minus, when you multiply this, is going to give us 0.9030. Now let's quickly check the calculation. That is 0.9542 minus 0.9030 is giving us 0.0512. It gives us 0.0512. So that's the answer. So it's approximately 0.051. That's our value. That's our answer. We look at the next question now. Question 5 says solve for s 2 raised to the power s plus 10 equals 10 raised to the power s plus 2. When you're solving this problem, you can have it this way. Log 2 raised to the power s plus 10 is equal to log 10 raised to the power s plus 2. And in writing this, we can have it this way. S plus 10 log 2 is equal to s plus 2 log 10 log 10. So in solving this one, there's a bracket here, there's a bracket here, so it becomes s log 2 plus 10 log 2 is equal to s log 10 plus 2 log 10. Now s log 2, we can now collect the like terms here. But before that, we know that log 2, we have log 2, s log 2 plus 10 log 2. Then we have log s log 10 plus 2 log 10. So in this, let us first of all collect the like terms. It's going to give us s log 2 minus s log 10 is equal to 2 log 10 minus 10 log 2. So from here we can evaluate s log 2, then s log 10. Let's go to the next slide. Becomes s into log 2, as we have in the last slide. S into log 2 minus log 10 minus log 10 is equal to, what is the value? It's given us 2 log 10 is equal to 2 log 10, then minus what do we have? We have not gotten here 2 log 10. I'm going to the last. We have 10 minus 10 log 2 minus 10 log 2. Now log 2 here we have s into log 2 is 0.3010. Here we have log 10. The default logarithm base is 10. So this will become log 10. This 10 equal to the same thing here. The default logarithm is 10. So we have log 10, that is 10 times 0.3010, which is the value of log 2. So from here we have s into 0.3010 minus 1 is equal to 2 times 1. Log 10 is 1. Becomes equal to 2 minus 10 times 0.3010 will give us 3.010. So from here we have s value will be equal to 2 minus 3.010 divided by 0.3010 minus 1. Now let us do our calculation quickly. Now we have 2 minus 3.010 will give us minus 1.01. That's minus 1.01 over. Then we have the next one, that is we have 0. That's 0.3010 minus 1, giving us minus 1.699, as we have it from our calculation. So now let's divide this. Let's divide minus 1.01 by minus 1.699. This minus 1, look at minus 1.01 to be divided by minus 1.699. So from here, our s value is giving us 0. Let's do it again. That is 1 minus 1.01 divided by 1 point. Is it 0? Is giving us this one value is not 1. This one is 0. The value here is 0. I put that one right. It's 1 where 0 we have here. That's 0.699. That's what we should do. Let me add that one again. Minus 1.01 divided by minus 0.699. And this gives us 1 point as answer give us 1.44. That's our x value. So that's the end. Thank you very much. Subscribe.